Assalamualaikum and good day. We are presenting our ECO3213 Mathematical Economics assignment on cost minimization using Microsoft Excel solver. The objective of this assignment is to determine the optimal combination of labor and capital that minimize production costs under different scenarios. For question A, we are required to formulate the cost function and the constraint function of the firm. Based on the question, the firm uses two inputs, namely labor represented by L and capital represented by K. The cost of labor is 10 ringgit per unit, while the cost of capital is 5 ringgit per unit. Therefore, the total cost function can be written as TC equals to 10L plus 5K. This equation shows that the firm's total production cost is determined by the amount of labor and capital used. The coefficient 10 represents the cost of 1 unit of labor, while the coefficient 5 represents the cost of 1 unit of capital. Next, we formulate the constraint function. The production function given in the equation is Q equals L raised to the power of 3/5 multiplied by K raised to the power of 2/5. The firm wants to produce exactly 120 units of output. Therefore, the production function becomes the constraint function. L raised to the power of 3/5 multiplied by K raised to the power of 2/5 equals 120. This constraint means that any combination of labor and capital chosen by the firm must produce exactly 120 units of output. The values 3/5 and 2/5 are given in the production function. They represent the output elasticity of labor and capital. This means labor contributes 60% to production, while capital contributes 40% to production. Therefore, labor has a greater influence on output compared to capital. For question B, we are required to set up the objective function in Microsoft Excel. The objective of the firm is to minimize total production cost while satisfying the output requirement. Therefore, the objective function is the total cost function. TC equals to 10L plus 5K. In our Excel worksheet, labor is entered in cell D20 and capital is entered in cell D21. The total cost formula is entered in cell D22 using the following Excel formula. This formula multiplies the amount of labor by 10 ringgit and the amount of capital by 5 ringgit, then adds both values to obtain the total production cost. For example, if labor equals 10 and capital equals 10, then the total cost equals to 150. To ensure that the firm produces the required output, we also enter the production function in cell D23 using the formula. In this formula, D20 represents labor input L, D21 represents capital input K, the exponent 3/5 measures labor's contribution to production, the exponent 2/5 measures capital's contribution to production. Excel calculates the output automatically whenever the values of labor and capital change. The objective function in cell D22 will later be selected as the solver objective cell, where solver will minimize the total cost while ensuring that the output remains equal to 120 units.
For question C, we use Microsoft Excel solver to find the optimal combination of label L and capital K that minimize cost while producing 120 units of output. First, we enter label L and capital K in cells C28 and C29 with initial values such as 10 and 10. Next, we created the total cost function in cell C30 using the Excel formula, which is equal to 10 times D28 plus 5 times D29. After that, we open Solver from the Data tab in Excel. We set cell D31 as the objective function and selected Minimize to reduce total cost. For changing variables, we selected cells D28 and D29. Next, we added the constraint that output in D31 must be equal to 120 and both L and K must be non-negative. We choose the GRG nonlinear method since the function is nonlinear. Finally, we click Solve to obtain the optimal values of level and capital that minimize cost.
Result level you must put 10. For capital you must put 10 also, and total cost you must make this. Plus 5 enter, output 10. Then you must go to solver. This mean enable, and then you must delete, delete, and delete. One to zero, equal to 1 to 0. Zero, this, this, equal to 0. This, delete, and make this equal to 0. Go to solver and OK. The answer true is this. For result D, label you must put 14, capital 5, total cost plus 5, output also 10. Go to solver, delete, delete, and delete. Solver and put the cost equal to 1 to 0. general equal to 0, and last general equal to 0. Okay, so far, okay, and this is the answer. The chair result C and D. For labor, result C decrease 13.5 units. Capital increase 31.96 units. For economic interpretation, the result demonstrates the substitution effect in production. When the wage rate increases, labor becomes relatively more expensive compared to capital. To minimize costs, the firm reduced labor usage and increased capital usage while maintaining the same level of output. This reflects the firm's effort to achieve production efficiency under changing input price.
For part E, I use the same solver model as part C. The cost function remains C equal to 10L plus 5K, where the cost of labor is 10 ringgit per unit and the cost of capital is 5 ringgit per unit. First, I enter the cost function C equal to 10L plus 5K into Excel, where L represent labor and K represent capital. This formula was used to calculate the firm's total production cost. I also enter the production function Q equal to L to the power of 3/5 multiplied by K to the power of 2/5, which represent the relationship between labor, capital, and output. Next, I used the same solver settings as in part C. The only change was the output constraint, which was increased from 120 units to 180 units. After running solver again, using the GRG non-linear method, Excel generated a new optimal combination of labor and capital that minimized costs while producing 180 units of output. After solver run, it automatically searched for the combination of labor and capital that could produce exactly 180 units at the lowest possible cost. So the result showed that labor increased from 106.97 units to 160.45 units, while capital increased from 142.59 units to 213.89 units. The minimum total cost also increased from 1,783 to 2,674. To analyze the change, I compared the result with part C. Labor increased by 53.48 units and capital increased by 71.20 units, and total cost increased by 891 ringgit. This happened because the firm wanted to increase production from 120 units to 180 units. Since more output requires more input, the firm had to use more labor and capital, which result in a higher production cost. Therefore, the solver results show that the output increased while input prices remain unchanged. The firm must employ more resources, leading to an increase in the minimum cost of production. For part F, the question asked me to explain the economic reason why the firm adjusts its combination of labor and capital when input price change. To answer this, I compared the result from part C and part D. In part D, the wage rate increased from 10 ringgit to 40 ringgit, while the price of capital remained 5 ringgit. Because labor become more expensive, the firm adjusts its input combination by using less labor and more capital. This is known as the substitution effect, where a firm replaces a relatively expensive input with the relatively cheaper input to minimize production costs. Based on the solver result, labor decreased from 106.97 units to 93.47 units, while capital increased from 142.59 units to 174.55 units. This adjustment allowed the firm to continue producing 120 units of output while minimizing costs. Therefore, when input prices change, the firm changed its combination of labor and capital to achieve the required output at the lowest possible cost. However, the total cost still increased because the price of labor become higher.